Today we'll see a typical classification of signal that is called as even and odd signals. So we'll first see some examples. We'll draw some waveforms. You know sine wave, okay? So sine wave is like this. Okay, we'll draw 2 cycles. Cosine wave. Okay, a triangular wave. Another simple triangular wave. Like this. A rectangular wave. Okay, now observing these waveforms, you can see that these 3 upper waveforms have some similar symmetry. These 3 lower waveforms are having some similar symmetry. Okay, so if we partition this wave, if we place a mirror at this point, so you can see in this lower waves, this portion is similar to this portion. This portion is mirror image of this portion and vice versa. But in case of upper images, if we place a mirror here, so this is not the mirror image of this part. So this is exactly similar to this. So this is not a mirror image. Here also you can see this is not a mirror image of this if we place a mirror here. But this is a mirror image of this part. Similarly, upper image is not a mirror image of this part, this part, and this part is mirror image of this part. Okay, so here these signals are having odd symmetry and these signals are having even symmetry. So these are having odd symmetry, these signals are having even symmetry. Okay, so if we fold the signal with respect to y-axis and the folded signal is similar to the original signal, then the signal is called as even signal. And if it's not, okay, it is exact minus of that signal, then it is called as odd signal. So we'll write for even signals, x of t is equal to x of minus t. Reflection of x of t is similar to x of t, then the signal is even. Okay, now for odd signals, it is not the reflection of the original signal. We will take reflection of this. If we take a mirror image of this signal, when the mirror is placed at this axis, so the original signal is like this. Mirror image of this signal is this part comes on the side. Okay, mirror image. Okay, and here we perform amplitude inverse. Okay, amplitude inverse will perform here. Amplitude inverse will multiply the signal by -1. So this part will go upside and this part will go downside. Okay, So this is amplitude reversal. So amplitude reversal and mirror image both are same. So in this case the signal is an odd signal. So for odd signals, amplitude reversal means minus of x of t is equal to the mirror image, means reflected image, x of minus t. So we can say x of t is equal to minus x of minus t. Okay. So these are the statements. For even signal, x of t is equal to x of minus t, and for odd signals, x of t is equal to minus of x of minus t. Okay. Now one more thing to observe in case of odd and even signals. Okay. So if you sum or integrate the signal, find the area for this even signal, you can observe that these semicircles are having same area. So this area is equal to this area, this area is equal to this area. Okay. So in case of even signals, the even part is there. So at the end you will get like this part. So this area is equal to this area, this area is equal to this area, this area is equal to this area. So when you are going to integrate the signal from minus infinity to infinity, x of t dt, that will be equal to twice of the area from 0 to infinity. In case of even signals. And in case of odd signals, if you don't observe this, starting from 0, this area is equivalent to this area again equivalent to this area. So this sum will nullify each other. And for odd signals, if you are going to sum this signal from minus infinity to infinity, these areas will cancel out with each other. So you can write x of t dt is equal to 0. So similarly, as we wrote equations for even signal and odd signals in continuous time case, where for discrete time sequences we can write for even signals x of n is equal to x of minus n, and for odd signals we can write x of n is equal to minus x of minus n. Okay. Now we'll take one example. So we can say for every signals we can find even and odd parts, and if a signal is even like this, so its odd part is 0. If a signal is odd by itself, then its even part is 0. So how to find even and odd components of any signal? There are formula for that. Finding out even part, x even of, let us say continuous time case, so x even of t is equal to x of t plus x of minus t divided by 2, and x odd of t is equal to x of t minus x of minus t divided by 2. So similarly you can write in case of discrete time sequences, x even of n is equal to x of n plus x of minus n divided by 2, x odd of n, x of n minus x of minus n divided by 2. Okay, so now we'll take one example. We'll take a unit step sequence and we'll find even and odd parts of u of n. U of n, so you know u of n signal. It is like this. It is a sequence of ones starting from 0 and so on. U of n. So finding out the even and odd part will require u of minus n. So u of minus n, we'll draw it here. So this sample will remain on this place only. Its amplitude is 1 and so on. So we'll write the time axis -1, -2, -3 and so on. Now for finding out u even part of n, we have to do u of n plus u of minus n divided by 2. So add these two signals. We'll add here. This signal is u of minus n, so we want to add these two. This one plus this one, so the sample is 2. At 1, 2, 3, 4 here the samples are 0, so here the samples are 1. Okay, and here also the samples are 1. Okay, divided by 2. Okay, so this signal is u of n plus u of minus n. Now we want to divide the signal by 2. Amplitudes are divided by 2. So u even of n signal finally will be this 2 divided by 2. The sample will be 1 and the rest of the samples will be half. So these samples are half. This is 1, half and so on. So the signal is u even of n. U even of n. So you can observe that this signal is looking like an even signal. So you can write this u even of n is equal to all the series of halves like this. At 0 it is 1 and again a series of halves. Okay, now we'll find odd part. Similarly for u of n we'll find odd part now. So we were having u of n, now we want minus u of minus n, so reflected. So we'll write here u of minus n. So u of n was like this, u of minus n was like this. Multiplying this signal, u of minus 1 was like this, multiplying this by minus sign. Okay, so this amplitude is -1. So you can write just u of minus n and then subtract the sample. This is one and the same thing. Okay, now we'll add those samples. U of n minus u of minus n, 1 minus 1, 0. all the samples are 1, and here on the negative side the samples are -1, the sample is 0, add 0 like this, -1, -2, -3, and so on, divided by 2, your odd signal. So this sample will remain 0, this is half, this is half, this is half, so all the samples are half. Again on this side dividing by 2, so all the samples are -half now, -1 divided by 2. So you can write U odd of n. This signals a series of -halves. Sorry, here 0 and we have half, series of halves on this side. So this is U odd of n. So you can observe the oddness of the signal here. And also you can observe one thing, in case of odd signal, here the 0th sample is always 0. Okay, thank you.